You have a 3D printer or you have access to 3D printing services. That's great. But maybe you're tired of downloading 3D STL files from the web. In this video, you'll have a chance to design your own parts for 3D printers. We'll design a planetary gear in Fusion 360. And thanks to my friend from Designwagoon Instagram channel at 3D Print and Art to Go, who supported me to 3D print these parts. We'll quickly discuss about FDM, Fused Deposition Modeling, one of the well-known additive manufacturing process of which my friend used in manufacturing of these parts. Well, it's so exciting. Before diving into the video, don't forget to subscribe to the Designwagoon channel and like the video. In this tutorial, we're practicing how we can design planetary gear step by step in Fusion 360 and some manufacturing advice. Let's get started. Hi, this is Cengiz from Designwagoon channel. As you can see, we 3D printed this planetary gear and it works perfectly. If you want to design and 3D print for yourself, keep watching this educational video and I'll share some manufacturing tips for you. In this tutorial, we're practicing together how we can design this planetary gear step by step in Fusion 360. Well, let's check how assembled these all gears using motion study. If you want to take a look at how we assembled gears, you can find the next videos on Designwagoon's YouTube channel. So, we can start with the base part of planetary gear. After you open a new empty model page, you can switch the Tools tab on the top of the tools. I'm using scripts and add-ins to create a spur gear, which is available in default Fusion 360. If you like to create your own scripts, this is the way to use your codes for Fusion 360. There is a friendly user interface to create your first gear in Fusion 360. Well, I will use one for module. Normally, it's so important for engineering projects, but I'll not explain deeply in this video. Basically, if you decrease the number, the pitch diameter will be decreased also. I'm entering 96 for the base part gear, 0.5 mm for the root fleet radius, 5 mm gear thickness, and 5 mm hole diameter. As you can see, pitch diameter 96 mm. Let's hit OK. After some computing in the background, bam! Our 3D print part is ready in CAD format. Now I'm opening a new sketch in XY plane. Press C key to draw a circle. 105 mm will be enough for now. Then hit the E key to use extrude tool. -2 for the first side of the extrude. Then I'm changing the direction as 2 sides and enter the -4.9 for the other sides of the extrude. But don't forget to change the operation to new body. Then hit the OK button. We need to erase the gear part using combine tool. You can select the cylinder part as a target body and gear as tool bodies. Change the operation as cut, so you'll get the base part of planetary gear after hitting OK button. Let's take a look at the FDM type of 3D printer. Basically, a FDM type 3D printer works by depositing melted filament material over a build platform layer by layer until you have a completed part. Materials for FDM include polymers such as ABS, PLA, PETG, and PEI, which the machine feeds as threads through a heated nozzle. To operate an FDM machine, you first load a spool of these thermoplastic filaments into a 3D printer. Once the nozzle hits the desired temperature, the printer feeds the filament through an extrusion heat and nozzle. As you can see, the extrusion heat are moving through x-axis and the plate is moving through y and z axis. Now we can continue to create smallest gear for the planetary gear. I'm opening the scripts and add-ins, spur gear. Then I'm changing the number of teeth to 24, then hit the OK button. But keep in mind, if you change the module, you can't obtain proper gear for your first gear. It should be the same module to fit each other. Yeah, my friend decided to locate the small gear in the middle of the building plate. In general, we prefer to locate the parts in the center of the plate's building table. It's okay, but if I give an advice about that, you can change the location after several prints because the use of your 3D printer at the same location will be making some balance problems on your building plate. Also, it's not so good for your shafts depending on your FDM type 3D printer. Our smallest gear is ready to use, so let's start to create 36 teeth last gear using scripts and add-ins. Spur gear, I'm entering 36 teeth, then hit the OK button. Now we need to change the position of the last gear. I easily hit the M key on my keyboard to open the Move Copy tool, and be sure to select the components as move objects. So we can arrange the position of the gear. I'm entering 30 mm to move the gear in the X direction. Also, we can rotate the smallest gear using the same move copy tool. Hit the M button again, then rotate minus 7.5 mm to arrange the proper position of the gear. Well, now we need to create two more gears, same with 36 teeth. I'm not using the previous operation that we followed. I'm selecting create and circular pattern. You can change the type as components. Select the 36 teeth gear as objects and select the circular edge or z-axis as axis selection. We can use the default quantity as 3 and hit the OK button to create other gears. Firstly, my friend decided to locate 3 gears as possible near to each other, which is a great decision because there are several positive outputs for that. The time. The duration of the print time is decreasing. The temperature of the material at the nozzle stay at the same temperature. Also, the printing materials are waiting for the next layer at the necessary temperature. Now we can start our last part for planetary gear. We need to design a driver part to move the old gears. Before that, I have to erase the small cylinder in the base part. You can easily push the backspace button on the keyboard, then it will be erased. After I change the visibility of the smallest gear part, I'm creating a sketch on the top face of the part. I need to reposition the view cube because I need the horizontal line for 2 gears. I have to say that we need to take into account we will manufacture these parts using a 3D printer. So we have to design the part thinking about the tolerances or clearances. I'm drawing a circle 4.6 mm in diameter. For other gears, we can use project tool hitting the P key on the keyboard. I'm using offset tool to hit O key on my keyboard. Then enter 0.4 millimeter. Also, to show you the other way of designing, you can draw the circles. Select 3 of them, pushing the Shift key on the keyboard. Use Equal tool from Constraints. Now I'm selecting Slot, center to center slot, to draw the driver part for Planetary Gear. Please attention here, if you wait for a second at any point, you can easily catch the snap points in Sketch as I did here. You can enter 10 mm and 40 mm for the slot. We will use pattern tool again, but this time in the sketch. I'm selecting create circular pattern. You can double click the slot line for objects in circular pattern tool. You can select the center point of the smallest gear as center point tool. Then hit the OK button. Now I press the E key to use extrude tool, then I'm selecting all necessary profiles to extrude them. You can enter 6 mm for distance in extrude tool. After we create the body, we can convert it to components. Select the bodies folder and right click on the body tool and select the create components from bodies. Double click on the new component to rename it, and I'm typing driver. Now change the visibility of unnecessary components because we need to create new small parts to hold the gears on the bottom of the driver. After you open the Sketch 2 visibility, hit the E key, then select the circled profiles of the Sketch 2. -5 mm will be correct for the distance in Extrude tool. If you have some issues to design these parts, drop a comment below your questions. I'll be happy to solve your problems in designing process. Select the out surface of the biggest gear, then hit the Q key to open Offset Face tool. Then I'm offsetting 1 mm the surface. Select the fillet from toolbar or simply hit the F key on your keyboard. After you select the edge, I'm entering 3.5 mm. Let's make another fillet to the driver parts. Hit the F key, then select the necessary edge. 3 mm fillet will be enough for this part. Change the visibility of any small gear and bottom part. Then select the bottom face of the driver and hit the Q button to open offset face. Well, I'm offsetting 1 mm to up this face because we need to add some tolerance value to assemble easily after we 3D print it. Also, hit the Q key after you select the top face and add 8 mm offset to hold the part easily. Well, I'm not satisfied the first value of the bottom face, so hit the Q key, then change the value as 2 mm. I'm moving on small part of the driver. Select the chamfer tool from Modify. Select all bottom edges of the small parts and add 0.9 mm chamfer. Because as you can see, the geometry will be allowed us to assemble the parts easily after we print it. For the last tip of this lesson, you can use the offset face. The shortcut is the Q on your keyboard and select all faces of the gear. For example, Then enter a distance minus 0.05 millimeter. It will give a more capability to move your parts after you 3D printed it. The distance value changes with respect to your 3D printer properties, but try to find the best distance value for you. I would like to mention how important it is to arrange the position of the part on the building plate. As you can see, my friend arranged the top of the driver part as on the building plates. This is very correct because there are 3 small end pieces. In this way, the printer doesn't need to make any supports. Well, I hope you liked the video, and if you want to create same design project, you can find the 3D files in the description of the video. If you like to learn much detail about 3D design and 3D printing, you can find the link to my basic to advanced Fusion 360 course below. And you'll have a chance to enroll with a discount coupon. And I have a question for you. What do you want to learn about 3D designing or 3D printing? Please just drop a comment below and let us know about your thoughts. We're also creating interesting videos on Instagram Designwagoon channel. You can also find the link below. If you'd like to see more tutorials about Fusion 360 and designing, subscribe to Designwagoon channel on YouTube. Hope to see you next tutorials.